Hey, Lawrence, we're back. Good to see ya. How's
Yeah,
things?
hi Laurie. Yeah,
How's
I
things
hope
in
you're well
UK?
later. It's mixed weather at the moment.
Yeah, it's
Cold
been
and
mixed
sunny.
here too. So I'm going to start off with a little bit of news that I just sort of ran across a little while ago, and I don't know, maybe about a month or so ago, I interviewed Einar Kusk from Finding the Curve, and it was about his new documentary series that he was making. And it was pretty early on in the whole thing. And so I wanted to sort of get it out there so other people could tune in and watch and follow the episodes. I think he got up to like maybe 5 episodes. And then suddenly he put out a sort of an APB that he was, which is All Points Bulletin over here in the States, that he was going to discontinue doing the videos, the documentary, and wasn't going to give any reason why he was going to discontinue doing that. And so I saw the video that or the comment that he made, because we're friends on Facebook, that he was going to discontinue without reason, which of course, you know, in the flat earth community, as in any community, you start getting gossipers and commenters and, oh, wonder why, and maybe it's this, and maybe it's that. Maybe he wasn't making enough money. Maybe the Illuminati got to him and shut him up. Maybe he got a job. I mean, it's kind of all over the place. And, you know, it's his prerogative whether to decide to say why he's discontinuing or whatever. I mean, it's his series. He started it. And I guess he can, like my dad used to say, I brought you in this world, I can take you out. So who knows? But it was interesting because he made a comment that that he was, I guess, making a video or something. And so he made a video, and it's what's his name in well, God, now I can't even think. Jim Carrey saying good afternoon, good day, and good night, or whatever at the end of the movie that he made, and walks out the door and so on, and becomes a free man. So people started then speculating, oh, he was trolling us. And, you know, I guess that's what happens when you don't explain yourself and you don't put out a viable explanation for people to accept or reject or understand or not. And then so I started reading the comments to see what people were saying, because that's usually where everything just starts getting really speculative and dramatic and rumor mills and all that stuff. And so I run across a comment that said it was that Lori from the Flat Earth Conspiracy Channel. She interviewed him and she talked him out of it, or I'm paraphrasing. I'm not going to read the comment. Well, I can read the comment. But of course, you know, I did one of those, what the heck? My fault? I mean, what? When you kick your toe on the corner of the bedstand at night, you scream my name, is it my fault? And so of course Jesse Spots jumps on there and he says, oh, it's Lori Frary, make sure you know the whole name. And then becomes even more speculation about, you know, she's anti-Dubé, and Einar was putting a lot of Dubé's videos and stuff in his documentaries, using them to convince his, you know, buddies that he was trying to convince, using, I guess, his 200 proofs or something. So I just wanted to say it wasn't me. I am friends with Einar on Facebook, and I did interview him, and I did put out some commentary to him in the interview, and that's up to him to decide what he thought about what I said, or what I said about the model being the wrong model that Dubé is promoting, and he's promoting Dubé. If what I said about that swayed him in any way, well, I actually feel good about that, because I would be remiss if, after nearly 2 years of Lawrence and I trying to debunk people away from the AE map and the Gleason map and the circle model and the circling sun and all that stuff, which many of us have proven to be untrue. And because there is media out there now, mainstream media, constantly adding another this or that about flat Earth, and every single time they use that model and that map and that whole circle, ice wall, dome, circling sun, the whole shebang that goes with it. It's our job as truth seekers to try to diminish that lie as much as possible. And those of us who started doing that early took a lot of heat and continue to take heat. But fortunately, there's plenty of other free thinkers out there who have done their own research into the problems that we have called out about the AE and the Gleason model and the circling sun and the single pole in the center of the Earth and so on. They've discovered for themselves that we're right, and that, you know, they're looking at other models. There's plenty of other models being looked at: square, diamond, Pac-Man, fourth dimension, torus fields. There's you know, several groups discussing it for hours and hours on end and putting in their speculations and their, you know, theories and their research. So it wasn't just me, but I wanted to bring it up because Lawrence and I both have certainly been blamed for a lot of stuff, causing drama and so on and so forth. And some of it, yes, we have initiated because we felt it necessary to get the dialogue going on why we feel so confident that the AE map and model should not be considered the official model of the flat Earth. So for those of you who have followed along with that for the last couple of years, both our podcast listeners and those who've, you know, watched our hangouts for hours ad nauseum, you can join along. And well, here we go with muting Lawrence right off the bat. So that's all I want to say about that. But I want to say to Einar, you know that I know, and I'm sure you've seen the comment from the commenter, and whoever Michael Pika is who made the comment, who has 0 subscribers on his YouTube channel. Shout out to you. It wasn't me, but thanks for the extra views on the video that I did interviewing Einar in the first place. And I thought then, and I think now, that it was an interesting concept to do the documentary. And so if you haven't seen any of the Finding the Curve, I still encourage you to watch it, because it's an interesting documentary on his talking to his friends and different people and watching as the thing evolves, and being accused of trolling his friends for flat Earth. I do believe that he was at least looking into flat Earth, and I think that he was more than intrigued by it. And whether or not he's flip-flopped and gone back to the ball, or whether he just isn't making enough money for his efforts, who knows? So anyway, shout out to you guys for your efforts. And if it turns out that Einar simply was trolling the flat Earth, he is an actor and he is a filmmaker. And if that's actually what he was doing and what was happening, well, then so be it. People will figure that out in the end, and it'll all come out in the wash, as they say. So, okay, Lawrence, I hope that you've got finished with your noise making over there. And hopefully you're going to talk with us about some stuff you've been finding out about compasses. And that I learned how to use a compass when I was a little girl. My grandfather taught me. He was a retired lieutenant colonel in the Air Force and was in the Army also. And he taught me how to use a compass. And I did learn how, and it does work within reason. And I did find my way home from the woods using it one time on their 77-acre farm. So I kind of think that in certain cases the compass works, but over a long haul, all this declination stuff comes in, and I'm not really sure I totally understand the concept of declination and all the mathematics that have to be involved in figuring out where the heck you are and where the heck you're going. So with that, what have you been researching?
Yeah, well, one of my conclusions, I'll give you one of the conclusions, Laurie, is everybody was puzzling about why at the equinox everybody sees the sun rise at 90 degrees and sets at 270. And I think I've got the solution for that.
Okay.
So I'm going to do a little screen share first, because these are my findings, and pretty... we've touched on this before. Let me share the screen.
Yeah, we did touch on it with regards to Google Earth, and how if you go east, you aren't going in any kind of a straight line. You're going down at an angle and so on. So yeah.
Okay, so let's take a look at this. All right, so what I've done here, gone onto Google Earth, okay, and charted a quarter of a distance around the globe model, from around 40 points along the same line of longitude. It doesn't matter which line of longitude it is. I think this is 60 west. And as you can see, east on the equator is actually west. But as you move up and you travel exactly the same distance, 6,225 miles, you end up at the same point as you would at the equator. And then you move up another five degrees. And again, I've got a bigger one, with more breakdown. But basically, every time you go up 5 degrees in latitude and travel the same distance, you end up on the equator. And it doesn't matter where on Earth you start off from. If you travel 6,225 miles and travel east or west, you're always going to end up on the equator. So my line of thinking here is that east and west is not subjective as to where you are. It's actually a fixed point. So you see my little pointer here. That's west, that's east, that's north, and that's south. So the east-west direction here, it doesn't follow the lines of latitude. Whereas on longitude, you head north on a line of latitude, and you'll stay on that line all the way to the pole at the top or the pole at the bottom. But latitude, I mean, it stays quite close to it for a while. So if you were navigating using a compass, you'd be okay for, a good few hundred miles before you were that far out. I had a quick look, and you could go about 1,000 miles on one little trial I did, and you'd only be 10 miles out. But when you start going vast differences, you're going to get huge. So the guy at the North Pole, let's imagine that there's a man at each of these points. Man at the North Pole, he travels west 6,225 miles. He's going to meet up the guy from the equator who's traveling the same way. All these distances are 270, on the compass, and they're all coming out at the same point. And if you went the other way, if you went east, you'd have exactly the mirror image, which makes me wonder, we've got longitude and latitude. We've got 360 degrees, of longitude, but we've only got 180 degrees of latitude. And maybe that's a clue as to where they're hiding something, because this doesn't add up to me. But if your compass, you look at your compass and you see the sun, at the equinox, rising at 90 and 70, setting at 270, this is what you're seeing. But it's not, relative to north. It isn't. But that's where my pointer there now is west. you get your compass out and it shows the sun setting in the west, it is. That's where it is relative to where you are, and it's the same for everybody. So, you know, the sun is plotting its way in a straight line over the equator, and everybody's seeing it from the ether. But when you're looking at the Google Maps, Google Earth here, there is only one west, which is, you know, which is there, and only one east. So wherever you are, whatever, if you're, you know, all these people on the same line of longitude, east and west is exactly the same for all of them, which is sounds a bit of a nonsense, but when you look at Google Earth, if what they're putting is correct, that's how it is. But we know the globe is a lie, so it would be interesting to see how this would pan out on the map. But they don't follow lines of latitude. But for navigation, you know, if you had a sailor, a ship that was doing, you know, 20 knots, and it went for 24 hours, at the end of the day, it might only be a mile out, because over short distances, the discrepancy is very low. But when you start going 6,000 miles, it's huge. So it sort of kind of gets exponential. The further you go, the more out you're going to be. So for general day-to-day use, people going out hiking and, you know, and going a few hundred miles, and they were using a compass, they're going to be pretty much spot on. You know, they're going to be quite close to where they intended to get to, and there'll be landmarks and things like that. But if you were in a long-haul flight, then you would hugely be out if you were trying to track your route along the line of latitude. And this probably explains why they've got great circle routes, because east and west is not east and west as we know it. It's not going around in a circle like these people who push the Peter Pan map, but it's doing what you would think it would do anyway. If you were designing longitude and latitude, you've got longitude all converging at the poles. Well, effectively with this, you've got the east-west directions all converging at the east-west. It's pretty freaky. So I started having some crazy thoughts that, you know, if I finish this side of the globe off, I would have, you know, something similar to a diamond type shape on one side, but there's also the other side to take into account of. So there'd be like two sides that would converge like this. And then I had the crazy thought that maybe it's not Pac-Man, maybe this realm that we live in has got two sides. And you think, well, that's pretty crazy. Two sides, you know, like two sides to a coin, although it's not a coin. But let me just play a little short video clip, because this is something else that made me think that. Let me just bring this up. This has been played before, but let's just play this. If I can find it. Where's that gone? It's not on that one. Is it on that one? No. Where's that gone?
Well, so Lawrence, I guess.
Oh, I've got it now. Sorry, I've got it now. Okay. I've stopped share. No, I'm going to play this now. It's only 2 minutes long. So let's play this. Is my sound coming through on this video?
No. No.
Not yet.
Does it have sound?
Yeah. It does. Can you not hear it?
No, just barely.
So try turning the volume up.
Oh, we've seen this video before. This is Mike Degree.
Yeah, okay. Can you hear it now?
Yeah.
Hang on, let me just wind it back.
It's pretty low and kind of garbled.
All right, well,
maybe you can paraphrase what he's saying.
Well, some people might not have seen this because he was out. Let's just let it's only 2 minutes. Let's just run it, and then we'll talk about it. Because
why don't you send me the link and let me run it, and I'll put the microphone down.
All right. I'll stop sharing. I'll send it to you in just a minute.
Okay, and probably should turn your volume back down just a little bit if you turned it up. So
Uh,
I have a question while you're sending me that. Of course, on that map that you were showing, the Google Earth map, it was a static map and you drew the lines. So as you would, as the world turns, meaning as you turn the face of the Earth globe while you were drawing the lines, would they come to the same point?
I'll show you in a second. Yeah, they do all come to the same point, but I've got that from another perspective, so I'll show you that. I'll just send you this video link first if I can get my Facebook working.
Okay.
There we go. I've got it. There we go. As people say.
Go there and get the link.
Okay. Right, I've sent it, you know. So play that in a minute. Play that in a minute. Okay, let me just come back in and let me show you it from another perspective. I'll get the screen back again. Hang on. Take that off. Right. Shortcut. There we go. So this is from a different perspective. Here we go. So here's all this. I've turned Google Earth round. So all these places. Okay, I've turned the Earth round on that. You can see that they're all converging at exactly the same place. So I've done it 5 degrees latitude, every 5 degrees, and also I've done the Tropic of Cancer and Capricorn. So all those places, that point there, right in the center where my pointer is, from those places at the top here going across, that is west for all of them, according to Google Earth.
That looks an awful lot like the international date line. Is that where that is?
No, I haven't done it. You could do this anywhere. You can do that anywhere on the globe. If you pick places at the same point, they're all going to end up at the same place. But you could pick any place at random, anywhere on Earth, anywhere. And if you travel east or west 6,225 miles, you end up at the equator. Doesn't matter where you are. We could do one at random now, and I could show you. In fact, I will. We'll do it at random. You pick a place anywhere on Earth. Anywhere on Earth.
Okay.
Hang on. Anywhere on Earth. Hang on. I've got Google Earth on here still. Here we go. Give me somewhere in the United States.
New York, New York.
New York. Okay. New York. New York, United States. Okay. Let me just take that down. Come on. Okay. We're heading for New York. The Big Apple, as they call it.
Mm-hmm.
Right, here we go. So there's New York. So we're going to head west for 6,225 miles. This is going to take us bang on the equator. So I'm going to start my, doing a line. New York. Hang on. Come on. Right, and I've got to zoom out a bit here. If it'll let me. Zoom out. Oh. I've got to move this wretched thing here somehow. Is that going to let me move it? All right, well, we know roughly where New York is, so I'm going to take that down and zoom out a bit. We know roughly where it is. Otherwise, it'll take me forever. Okay, so we'll start again. There's New York, and we'll head from here. We're going to go 6,225 miles to the west. 270 degrees. So you can see on the heading, it's around about 270. But you'll see, sorry, start again. It'll take me a minute. Let's go back.
Probably took you a while to do all of those 6,225 miles from all those latitudes.
It did, yeah. Okay, sorry. Where was New York again?
Yeah, just start somewhere in there. Okay, yeah. The little red dot.
Okay, right, here we go. So 6,225 miles of 270 degrees. Hang on, let me put the grid lines on so you can see it. View grid lines. So you can see where the equator is. Okay, clear that. Start again. And it was that red dot. Okay, so 6,225 miles at 270 degrees. Six thousand 300, 6,200, and 6,200. Well, you can see anyway, 6,218 miles, 270 degrees. So that's west, yeah?
Okay.
Okay. So I'll save that. I'll just call it New York. Okay, and then let's take you where you live, Sarasota, somewhere down here somewhere you are, aren't you?
Yeah, right in
So
the
you've seen that
side of Florida there.
Yeah, so you've seen that one.
That's pretty wild.
That's headed at the equator. So he went out of your house and could get in a
well, I mean, we already know that following west does not. We already discovered following west does not follow a latitude line. We already know that.
All right. Well, here's you somewhere around about here. Yeah. Now you're going to go 6,225 miles west as well. Let's see where you end up. You can see the heading. There we go. 6,232, 270 degrees. So you can see, there we go, that wherever you are on Earth, oops, sorry, I lost that one, but you can see then that it reached the equator. Let's do it again, just so people can see, and then we can show them both and the different what's it's. So there we go. God, once you start doing this, when you make an error, you have to redo it.
What inspired you to do this, Lawrence?
Oh, just a random thing. Here we go. So there you go. That says 6227, 270.23 degrees. But you can see wherever if you travel that distance, you would end up at the equator. So let's just save that as Sarasota. Okay. And we'll go to the UK. Somewhere in the UK. Okay, so we're over here. Where am I? Around here somewhere. There we go. Let me just get north back up so I can get my bearings. There we go. So there's the UK. I'm somewhere up in the north of the UK, and I'm going to travel 6,225 miles. You'll let me get on it. Here we go. $3,100, $3,800. There we go. Getting the car seat with us, don't you? There we go. 6,002.
Well, your degree of angle is way off, so you need to go west. You're at 312.
Yeah, just a minute. Just let me start that one again. I must have done something wrong. Okay. Right. There we go. Start again. There we go, 6250, 6237, 62. There we go, 6219270. Yeah, that's on the equator. So wherever you are, you're going to end up on the equator. And it's the same if you're in the southern hemisphere. So obviously on the globe, it's bringing you, if you travel west or east, it's bringing you down. It's bringing you south as well. But let's say you're in Australia. Here we go. Somewhere over here, and you travel 6,225 miles west here. This is where it's going to take you. 270. There we go.
Heading 270.
Oh yeah, 6,000.
They're back. Yep.
6,223, 269 degrees. So you can see from that, doesn't matter where you are, anywhere on Earth, 6225 takes you to the equator. So
that is
east-west
so
does not
bizarre. I can't, the only thing that I mean, I'm automatically noticing, obviously, that that east and west have nothing to do with the lines of latitude. That's for sure. And
yeah.
I would assume that because it's a ball, it's got something, the way that they've created the angle of the ball, that 6,225 miles is going to go around the curve. And I totally do see why they do the great circle routes, or why they look like great circles.
They have to, because east-west
They
is
have
not
to.
east-west, apart from on the equator.
Right.
So you go
but
on the
it's
equator,
also, yeah, but it's also because it's curving on a ball when they're laying out the routes, and it has nothing to do with lines of latitude or longitude. It only has to do with direction, angle of degrees. Hi, John. John's joined us. John Walicki. How are you?
Travel west on the equator, and it's a straight line.
Okay, so John just joined in. I don't know if you've been watching for a couple of minutes before you got here, John, but Lawrence has discovered that when you plot a course anywhere from anywhere, 6,225 miles due west, 270 degrees, you end up at the equator.
Or east.
That's fascinating.
Go east or west, you end up at the equator.
Yep, wherever you start.
So my first question is going to be, how is this compass reading determined? It is obvious that it is not determined by the North Pole. If this is the case.
Yeah. Well, I mean, let's just
wait, Lawrence. Do you agree with that deduction, that it is the North Pole magnetism, blah blah, is not what's drawing the compass to north?
What I think has happened is that obviously people have to navigate on Earth, and the powers that be have told us that it's a globe. But you couldn't navigate on a globe with a compass. It simply wouldn't work. So what they've done, they've invented these magnetic fields, which they say distort the compass, to compensate for the errors that would be on a globe, even though it isn't a globe. So I think people think they're compensating for some magnetic field. It's not. It's compensating because it was a lie in the first place.
Okay, so these declination charts that we've been seeing lately.
Let me bring one up.
If you can bring one up, that would be helpful to view.
John, did you see this image before?
Yeah, I was looking at that. Yeah, that's nice.
Okay, so let's look at declination. So you can actually go and look at magnetic declination. And apparently they've got these stations all over the world with all this so-called high-tech equipment, which nobody understands, working out what the magnetic declination is. But I think it's just a load of pseudoscience. So you can click anywhere in the world and it'll tell you what the declination is, which is, you know, how much you're going to be out from what the true reading's showing. So down here in Antarctica, it's saying the magnetic declination is minus 177 degrees. So effectively it's saying north is south.
Yeah, so that's almost 180 degrees. Yeah. Yeah.
Yeah. So how would anybody navigate, you know, prior to, you know,
well, if you're talking about
so to explain, okay, so to explain, minus 177, or let's say 180, minus 180 if your compass is pointing north, which is minus north, it's pointing south. So you would have to correct it 180 degrees.
Yeah.
Yeah, well,
Okay.
give or take a little bit more, the 177. That's
Okay,
yeah,
but I'm saying you would have to nearly reverse
it's
what
still
the
a pool
compass
table.
is reading.
It's still a pool table down there. You're just like banking it off the turnaround. But yeah, it's funny. I mean, in North America, you have a declination of 14 degrees about to the magnetic north. And, you know, it's funny what you were saying, Lori, is that, yeah, they don't use any magnetics to, you know, chart courses like back in the day. I mean, the only thing, I mean, they did understand declination. They had dead reckoning, but really what they looked at was the Polaris, the North Star, because they basically measured everything via that. So, you know, they tried to, I guess, get, you know, a general straight line course across the latitude, I would say, maybe.
But were they even using compasses that far back? I thought they were using, what is it, the sextant or the astrolabe or what was the early tool they used?
Yeah, there's the sextant. Yeah, the astrolabes for judging the night sky, I guess.
In the very old
versus the horizon. I'm really not sure. It's old tech.
Well, and there you go. None of us are really sure, except for those people who call themselves experts act like the rest of us are dumbasses because, oh, you just don't understand declination and you don't understand, you know, the equipment that we're using. You're just not educated. You don't know. And then it's like, okay, cool. Well, then why don't you educate me on what it is you're doing?
Well, I have some education for everybody.
Okay.
I'm reading from a Boy Scout manual from 1989, the first chapter about the compass. It says the first compass appeared in China 1,000 years ago and in Europe 200 years later. Travelers noticed that a magnetized needle floating on a chip of wood always swung around to point north. Many people thought the needle moved by magic. Some still do. Yeah.
Right. Some still do.
Prior to the compass, they used to use a thing called a wind rose, where, you know, they would take the directions of the wind as a cardinal direction based on, you know, past experience. And the compass was a follow-on from the wind rose. In fact, it's featured in the design of compasses today. But look at this chart here. This is all the magnetic fields, allegedly, on Earth, all of which would affect a compass reading. How on earth did anybody get anywhere?
Well, especially because several of them do complete 180s. And there's one there off the coast of South America that is a circle. I mean, it's a elongated circle and everything circles around it.
Oh, you get lost for sure there.
Yeah, and that's not the Bermuda Triangle. So,
yeah. But,
okay, so I'm going to make. Go ahead, Lawrence.
I was just going to go back to, you know, I sent you that video link for Mike Degree. We can show it again in a minute. But my theory here is, because when John came up with the half collignant, it got me thinking that you've heard all this, you know, as above, so below. And yet this Mike Degree, there was an ocean beneath the ocean. What if there was a world or part of Earth, half of it's on the top and half of it's on the bottom, and the ocean beneath the ocean is the ocean on the reverse side of what we are. So what you'd have to do, you'd have to cut the map in half somewhere and put the bottom on that on the bottom of it. And obviously, there'd be some point where you would transfer to the other side, and it might be the international date line. But I mean, that sounds as good a theory as anything to, you know, as an alternative to Pac-Man.
Well, you know, Pac-Man can, yeah. Right. Two sides of the coin, and then you have the
I mean, why have we got an ocean beneath an ocean, which we can't go into? That ocean must belong to another world. It has to. What world? Is it the other? Is it part of Earth? I mean, that guy died shortly afterwards, which sounds a bit super, you know, suspicious. But let's imagine that they could, he went back and they had a closer look, and they started swimming around there. And if they saw the fish swimming upside down, fucking hell, that would be a bit of an eye-opener, wouldn't it?
Well, that reminds me of that cartoon movie of the Big Giant. What was it? Big Guy or Big Giant? What the name of it was? I watched, and they had over water. They had a mirror reflection, and everything was in reversed in that movie, and it was supposed to be mythological. But let me play the clip real quick, Lawrence, and
okay, we'll come back to these things.
I get to what was it? Okay, ocean floor, share. Nice. I haven't gotten one of those in a long time. So stop. Share screen.
Well, so while you're doing that,
this one, here it is. I've got it. It's not that big a deal. I just got to do the right screen. Okay. All right, quit with the music.
One of the strangest places on the ocean's floor was only just discovered in the 1990s. I might agree it's one of a handful of people to ever see it in person.
Without a doubt, one of the most amazing things that I have ever seen in the bottom of the ocean. It was while filming for Blue Planet in the Gulf of Mexico. I noticed there's something out in the distance. Couldn't tell exactly what, but it looked like a dark band. And as we approached it, the dark band became a donut. I saw this donut. It was black in the center. What the heck is that? And so as we get closer and closer to it, I noticed that the black band had what appeared to be kind of steam over it. And then I looked, and there was water lapping against the shoreline. This band was a ring of mussels. And inside the ring of mussels was a lake. And it's like, wait a minute, I'm already underwater. We went out over the water in this lake and tried to descend in it and bounced off. It was so super saline and dense that the submarine couldn't go down in it. We literally bounced off. And as we bounced off, we sent ripples heading back to the shoreline. It was insane. I've never seen anything like it.
Isn't that guy dead now?
He died shortly afterwards, yeah. And maybe they didn't want him to go back looking because, as I said, if you could see fish swimming upside down, then you've got a parallel world, haven't you? Or the other half of the earth.
Well, it reminds me of that Black Mirror in the Matrix where Neo like touches out to it, or the silver, or it's like I don't know, it's like a few different things. Yeah.
Yeah, but why have you got twice as many longitudes as latitudes? There's no logical reason for it at all, unless there's one half relates to the top and the other half relates to the bottom.
As above, so below.
Let me share another screen with you. Let me go back through some of these bits I've put together. So what we've got here, in a minute, there we go. This is the reverse side of Google Earth that you rarely see. And all of it, apart from a few tiny dots of islands, is ocean. That doesn't sit well with me. I don't think that is all ocean. There may be bits stitched in to fill the gap in the globe. But that bit there is 50 million square miles of ocean. Because you can actually go on Google Earth and draw a circle, and it'll give you the square area. 50 million square miles. How on earth would anybody navigate across that? It's just enormous.
Well, I mean, we're told over and over about shipping lanes, and they don't get that far off of the shipping lanes. And they use the reasons pirates are out there, but most of the cargo and large ships, container ships that are going back and forth across the Pacific are all staying within a pretty tight lane. So they're actually not like really navigating. They're just following a plat map.
Well, and if it's like a train of them, a convoy of them, they can basically keep sight of one another, you know, like elephants walking. So, you know, if they do veer from a course, you know, they at least know where the group is going in the lane.
Well, and we've all done our little treks around Google Earth by, you know, going off into areas like this and zooming in and seeing all the funky stuff they've drawn on the bottom of the ocean. Like they've literally, you know, scanned it all and know every little bump and mountain and whatever.
Well, it's fascinating. The Pacific Ocean is so vast and wide, yet if you look underneath it, there are vast mountain ranges that you're like, okay, are these volcanoes? Are they going to breach the surface of the water? Is this going to be, I mean, there's vast patches of just, I mean, mountainous terrain that's like just poking, you know, just sitting right underneath the water in shoals and everything. And you got to wonder, like, okay, well, if the water seemed to drain on one side of the earth, you know, into a big hole, that might be a lot of square miles for new real estate.
That's an interesting concept in itself. Okay, so Lawrence, what's drawing the needle on the compass?
Well, I had a chat with you, Laura. You said it might well be the sun.
Well, I think it has something to do with the electromagnetic field created from the sun. And because the sun stays in the same relative position between Cancer and Capricorn all year long, it might be interesting to look at the declination patterns and see if that has any relationship to the sun's path moving north and south, back and forth in this so-called sort of giant sine wave. I don't know, but it just came to me, you know how when you and I talk and we just are throwing stuff back and forth that we're researching, it, you know, something just pops into my head, and just like a long time ago, it popped into my head that we've got a pyramid overhead. I don't know that it's any kind of a glass dome pyramid concept, but there's something to do with the angle of the celestial bodies as they pass over that tells me it just seems like on the equinox day, the sun is riding the top of the pinnacle of the pyramid. And that is why it looks like to everyone that it's coming in at 90 and leaving at 270. And it also would explain why people in the far north and people in the far south think they see a circling sun or an arcing sun. I know I see it where I live. I'm north of the Tropic of Cancer, which all of North America is, and well, at least the United States up, and the sun appears to rise north of me, and arc backward over my head and leave north of me. Northwest comes in at northeast and goes out at northwest. So if I were to be fooled into believing that the sun was going in a circle, it would certainly look that way. And I can totally understand why people up in Alaska and in the far north are so adamant that they see a severely arcing or circling sun, and hence the reason why they're so into the AE map model with the sun circling the North Pole in the center. I can totally see why they think that, until somebody from the far southern hemisphere plane, blah, blah, jumps in and says, hey, wait a minute. I see the sun come in south of me and arc overhead and go out south of me. And how can that be if it's circling the middle, you know, on the AE map? So that's been a big part of the debate for years now in the flat earth community, because there are so many, 90% of the population lives north of the equator. So anybody who comes in south of the equator and starts saying, well, wait, this is what I see, you know, it's pretty easy for the northerners to go, you don't know what you're talking about. You know, you're wrong. That's not how it works. Even though it's like, no, that's what I see. I can measure it. I can show it to you. So, but this curious part is this. First of all, how did you arrive at 6,225 miles at 270 degrees west? How did you arrive? Did you just draw a line west and then you ended up at the equator, and then you just started doing it for all the other places, and then lo and behold, they were all 6,225 also?
Yeah, it was purely random, Laurie. But
Okay.
Let me just bring Google Earth back up again. And I'll put these lines back on. Just bear with me a second. There we go. Because I took them off. Let me just take those off. And I'll put the others back on if they're on. Here we go. And I'll show you something else. Take a minute. Just bear with me. But yeah, I mean, this declination business, you know, is just, and they make it sound so complicated, and the equipment they use is very supposedly high tech that nobody's ever going to try and understand it. They'll just take it as read. But I think it's just pure pseudoscience to cover up the fact that we're not on a globe. And navigation over short distances, going east or west using the compass, is going to be accurate. It's only when you go on long distances that.
Well, what do you think, Lawrence? What do you think? Let me put you back up there. What do you think the percentage of people out there traveling using a freaking compass nowadays is? Hardly nobody. Everybody's using a GPS, or they're using their phone. And so they don't give a diddly about declination, because they don't have to sit down and figure it.
Yeah.
They don't have to get out a chart, and they don't have to, minus 177.5, and they don't have to do any of that, because it's all figured for you.
Yeah. All right. Well, let's find somewhere in the States on this line of latitude over here. Let's go to that and see how far you can go before you start veering, a lot off the latitude. So we'll zoom in. I don't know where that is. Carolina or somewhere, is it? Hang on.
Yeah, there's not very far.
All right.
What is one of those grid lines? What's the distance on one of those grid lines? A degree?
I'll have to measure it. Okay. You can see, so if you're at that one near Nova Scotia.
So it's a degree.
So that is that particular one there on my pointer. It's staying on the line, but by the time it gets onto the third one, it's veering off. So you could travel that distance, which is, bear with me, from there to there is, it's about 50 miles. And you actually, for one of those squares, you're going to stay on the line of latitude. So if you were navigating, if you were going on a 3 or 4 day hike across the mountains, you're going to stay pretty much on track. You're not going to be very far out. But as you can see, that line there, there's a divergence. And the more you move across, the more you're diverging away from the line. But people, day-to-day use, people using compasses.
Isn't the miles to the horizon just about 50 miles? Like, for as far as you can see to the horizon, they estimate it's like 50 miles. So it's like, what, every 50 miles you have to, make a new waypoint and shift?
I don't know what
I'm thinking about.
You're talking about line of sight?
Well, yeah, I mean, like they say,
Yeah.
like if you look at the horizon, you know, you can I mean, if you're generally flat area, you can generally see about 50 miles. Like that's how far it is to the horizon. That's what I always heard when I was younger.
At
So
how
I'm
many
going.
at how many feet above the ground? You're
Well,
not
I
talking
mean,
about on the ground.
yeah, I'm talking about on the ground. Yeah, like
Huh.
if you're like sitting and looking out at a flat horizon, you can generally see about 50 miles. That's what I always understood.
Well, I always understood it to be like 3.5 or 4 miles.
Oh, oh no, I mean
Like
like
if
because you.
you're looking out over the ocean, you know, let's say you're standing on the beach and you're looking out over the ocean at sea level.
Well, I mean,
The ice.
Michigan to Chicago. I mean, you know, that's what 90 miles. So there you go.
Mm-hmm,
I mean,
mm-hmm.
but you only can tell that you're looking at the other side because you know you have those
You see
skyscrapers,
buildings.
right? Exactly.
Right,
So that's how you can
right.
judge that. But yeah, but you know, there's still that interference and everything. But no, I'm saying so. If Lawrence has figured out that what you can go every grid mark is what 50 miles, about. So
I forget what a degree of the UTM one
mm,
degree is. Probably could look it up real quick, but
Yeah.
seems UTM grid 1 degree. Come on. How far is 1 degree? They want to start giving you a whole education on the UTM before you can just get what you want. Okay, let's see here.
Yeah, but what can we conclude from this, Laurie, John? You know, you've got east-west that are converging, you know, at the West Pole, if there was such a place as a West Pole, and north-south, they're all converging. So
so wherever you
northern
are,
line
there's a vanishing
follow
point.
longitude. They follow it precisely. If you go north, you stay on the same line of longitude. You can see that on the degrees there. Look,
Yeah.
360 degrees. You know, it's staying on that line. But when you go the other way, it doesn't. So it doesn't make sense. That is the flaw with the globe. You know, so only when I did the the Calignan map and drew it and plotted all these cities on, if I was looking at something that was going, you know, pretty much straight down, like from the UK down to Cape Town, which is, I know it's a bit off straight north, the distances were pretty much spot on. But if you were going heavily east-west, you know, you were getting the Great Circle routes. So I think the map is accurate, although, you know, we have a problem with Pac-Man and people won't buy into it. And they'll probably have an equal problem buying into there being two sides of thingy. That might be something you could have a look at, John, and have your half Calignan on one side and the other half on the other. Just a question of where you would say the switchover is.
Yeah, you know, I do like a simpler form. I'm still struggling with that. You know, the only reason I went with the half Calignan recently, veering off, is I keep thinking about triangulation. When you think about everybody that's ever navigated, they always use triangulation. And hi. And so, you know, it dawned on me that every point on the map is basically connected via the old lines of triangulation. They mapped it out and they made whatever grid over top of it. Okay, that's great. But then you get these science guys talking about the heavens, saying there's a triangle and it's flat. And I actually found 2 years ago, was it 2 years ago? Neil deGrasse Tyson's actually talking about the same thing. And it kind of boggles my mind. It's the only reason I went there is because I don't know. There's a lot of issues. I'm sure people can come up with a lot. Laura, you mentioned a while back the four corners of the Earth, and you know what's really a corner. If you look at the north or the south, those aren't really those are corners. If you want to look, I mean, but they're not corners on a globe. There's no corners on a globe. If you take a look at the diamond map, the north and the south would be considered corners, but the side to side, they're just, you know, Pac-Man in and out. So there's no corners there. So there's only 2 corners there on that map. And which is why I went to, you know, a sort of like solid shape. Sorry, I have to go back a little bit.
The triangle, right?
Yeah, you were talking about, you know, the angles of the light coming through from above. Mm-hmm. Now, you know, you got to consider that the Earth is above the Earth. You've got all these levels of air and density of air and particles and mixture of 2 until you get to a relative, I don't know, near vacuum or vacuum. Well, if you have that ascending density change, atmosplanar change, pressure-wise, particle-wise, you're going to have different angles of refraction. So if you're looking at a light coming up from up above, I mean, what's the angle? Is it infinity? I mean, it's near infinity from wherever you are, because you're going at, you know, closer and closer until you reach infinity. Because until you get to the vacuum, that's what I see going towards infinity. But there's that barrier of, okay, well, are you at infinity? Or are you still in some sort of particulate chemical volume? And so that's really what I was sort of considering the 4th corner. Lawrence brings up a very interesting idea about the flip side. And, you know, I mean, if you can have Pac-Man in one model, you can have Pac-Man in any model, which is kind of nice. So I didn't quite think about that, a triangle on top of a triangle underneath. That's fascinating. Although that would be too that still would be a dual polyhedron.
Well, let's go back to the as above, so below. Let's combine that with the classic 2 symbols used by the Freemasons, which is the compass and the square. And when you put one like this and one like that, what do you end up with in the middle? Okay, you end up with a diamond, but or a square, depending. But these 2 shapes don't have to overlap each other. They can actually be pulled apart and go one on top of the other and end up with that, right?
Or it could be a flat
an hourglass, okay.
Or it could be a flat
are these shapes
flat?
Well, yeah. I mean, it could end up making a hexagram. It can end up, you know, however you take those 2 shapes, you can make a lot of shapes out of them.
The chestahedron.
But you take the as above, so below concept, and you take those 2 shapes and separate them. You know, part of the illusion is that they're overlapping each other and making this thing, right? So all I'm saying is, and I'm going to repeat this sort of ad nauseum because I think it's important, what the shape of the flat terrain of the Earth is not totally relevant to the shape of the celestial plane. They are 2 different planes. They have 2 different properties. Terrestrial land, okay, is one surface, one plane. It does interact with or get to view, whichever way you want to look at it, what's happening above. The shape of the above plane does not have to be the same as the shape of the below plane. Okay. Many people see the circle and the little dome over the top, and they think the stars are going around this dome, and they think that explains everything. Well, it's not quite that simple, because the angle of the celestial plane, we don't know if it's just one plane. We don't know if it's you know, here we are and here it is at 23.4 degrees of angle. How does that affect what everyone below sees? Okay. And then you add in, okay, well, then we got the star trails going in two different directions on each end of the plane. Does one plane above create that effect? I say no. Okay. So let's add another plane. All right. And let's put an apex at where the two planes come together. And as whatever's going south on, let's put that plane with a, you know, an apex at it, long. Let's run the sun across the equator. It's going to look different from everybody, as Lawrence just showed. East and west on those on the Google Earth map, in my opinion, represents the path of the sun. Okay. Now, I don't know how I'm able to say that's what I see out of it, but that's what I see in my head, because on the equinox, every single person, north and south, ends up converging their 6,225 miles, which is, Lawrence, might be the distance the sun is from the Earth. 6,225 miles. As they see this sun pass over, they get this different angle from it because of the refraction of the ceiling inside. This is the part we view. We're looking at it from down here. So it could be going in a completely straight path, but appear to be not. And as it goes south of the equator or north of the equator, Cancer to Capricorn, still in a straight line, that's when it appears to curve, just like those great circle root lines that Lawrence is drawing on the globe. This is all the reasons why we've been able to be fooled by the globe. I still, to this day, even though I know I live on a flat plane, and even though I know the sun's traveling in a straight line, to this day, if I see one more of those videos with the sun in the clouds, right? Looks like it's in the clouds, and it looks like it sets below the clouds. If I see one more of those, I mean, you know, there's no physical way that the sun is at the same altitude as those clouds, right? Does everybody agree with me on that? That the sun is not at the same altitude as those clouds?
Oh, absolutely.
Okay.
Yeah.
So
I would question if there even is a physical sun at this point.
Well, okay. Did I send you the video of the guy that made the video about the sun is a filament? It's not the physical sun, it's a filament.
Yeah,
okay.
And after that light,
quite intriguing concept he came up with. You know, that's thinking outside the box, because ever since then, when I saw, you know, I look at the sun, I'm like, it's a filament, like in a really bright light bulb. And how many times have you looked at a really bright light bulb filament? You know, I mean, I've seen, what's the highest wattage of a light bulb you can buy? I mean, they have them, mercury vapor or whatever, for giant warehouses are really bright, but they're way up there. So you don't, you know, you're not staring right at the light bulb. But it burns your eyes, or feels like it's burning your retina, and makes you not be able to see anything for a few minutes when you look at it. And the same as the sun. So very interesting concept that the sun is a giant filament. So what is that giant filament attached to? And is it inside with us, or is it above the so-called firmament? You know,
and
we're stuck on this word firmament, but why do we have to keep using that word?
Filament, firmament, they sound so similar.
Yeah. Yes, they do. Curiously.
I would hence to say that at this point, it's really beyond anyone's ability to model physically, or even on a computer. I mean, you can point where things are, in time where they will be, sure,
Well,
like
of
the eclipse,
course.
but
And you know what?
that's
And
about
you know
it,
what,
folks.
John? That's why looking at NASA models now used to look like, wow, it's brilliant how they figured all that out. Now you look at them and you go, God, this is so simplistic compared to how it must be.
2 years ago, they're saying that the universe is flat. The universe is flat as of 2 years ago. Okay, so how does that affect a round Earth? And Neil deGrasse Tyson, if the Earth is so oblately sphere at the equator, well then how come Google Earth got it so wrong?
Yeah.
What the fuck?
How can anybody find their way around the southern part of a perfect sphere?
Well, is it a red herring? Is it a red herring? Because clearly he's not in line with everything that Google, has shown us on a Google Earth. So
Or
is this a red
NASA?
herring? Or, I mean,
Yeah, every NASA model is a circle.
He can attest to a flat universe above. And how does that correlate with a round Earth that isn't modeled the way he actually presents it in his words? I don't know. It does not compute. Does not compute.
Yeah. Well, what do you have, Lawrence?
Yeah. So, I had a quick search on asking the question: do lines of latitude run from east to west? And they all say they do. So here's one here. And this is about navigating. Modern survival blog. Lines of latitude run parallel to the equator, east to west. They may run parallel to the equator, but they don't go east to west apart from on the equator. So that is a huge lie. But let's just take a look now back on Google Earth. Okay, so we've got these people. Let's assume that it's March the 21st, that it's the spring equinox. Yeah. And there you are somewhere in America, up there somewhere. And you're seeing the sun setting in the west at 270. Yeah, let's go 6225 the other way, and you'll see the sun rising at 90 degrees. Let's just do one. Let's just make one of these lines go the other way. There we go. Let's get that one. So we're going 90 degrees the other way. Oops. Anything this is. There we go. There we go. Here we are, nearest damn it, 6236, 89.41. So that's where the sun is. It's on the equator, yeah? And wherever you are on here, you're going to be seeing the sun rising at 90 degrees and setting at 270, And I think Google's telling the truth with this stuff here. But people, this is something we've took it a stage further here. So that explains which the Globers say, well, how do you explain that? Well, there it is. That's the explanation.
What do you mean you think
lines do not run? Go on.
What do you mean Google Earth is telling the truth here?
They're showing you that east-west they're not parallel to the lines of latitude. But
okay, so
that was look at they said Mercator, brought out this map so that you've got your lines of longitude and latitude to make sailing easy, and it does, but only because a sailing ship's only going to go at 20 knots. It's only going to be sailing for a few hundred miles a day, isn't it? Because voyages took months, so they would be okay because they were using other, they were using chronometers and sextants and other instruments, so they would still get there. But if those ships were traveling at 500 miles an hour, they would never get to their destination using those instruments. The compass just wouldn't work.
Okay, so does this feedback? Hate that. Okay, I gotta mute you, Lawrence. I'm sorry. Okay, so the it probably doesn't have anything to do with anything, but the so-called path of the eclipse, you know, everybody's sort of freaking out. I've been watching all these different videos. Oh, it's going the wrong way. Why is it only 70 miles wide? Why is it going from west to east? Why is it going down at an angle? Well, the angle, west to east, if you were to pick the line of west to east that this thing's supposed to be tracking, and draw your 6,225 miles east to west or whatever, it definitely would arc down that way, because you've already shown that any place goes to the equator, right? At 6,200. Oh, I got you muted.
Yeah, it's not a 70-mile wide shadow. That's just a 70 miles diameter at any one point in time along the path that anyone can see the perfect eclipse. That's not the shadow. Right. So
right.
I mean,
I
Richie from Boston's got it freaking wrong. Sorry.
I mean, there's a whole bunch of people that are saying that, though.
They're portraying it wrongly.
This destroys the flat Earth, or this destroys the globe Earth model. This, it's only shouldn't be a 70-mile wide shadow. The shadow that they're showing, okay, this is probably going to get people to go shill again. But you're in agreement with me, John.
Yeah.
The model that they're showing of the 70-mile wide path is the total eclipse block out of the sun, viewable from the ground, where the moon blocks the sun. Okay, that's
absolutely correct.
That is not the total path of those who will see the eclipse and or its shadow. Okay, and they're confusing this issue with shadow with amount of light unable to pass the sun to get to the ground, which is just going to darken the ground like a freaking cloud does when it goes overhead, okay, between you and the sun. Then I'm hearing the width of the moon must only be 70 miles because that's the width of the, and it's like they're combined. This is another one of those things where you do the eye roll and you go, you guys, you're making us look stupid here because we don't all agree on what it is you're saying. And, do we need to come up with another term for flat earthers who don't believe the common dribble coming out? And most people, and I don't say this as being cruel or calling anybody stupid, okay? Most people do not have the time, wherewithal, or ability to check their work. All right? In other words, if someone draws you some convoluted math equation, if you do not know even what the symbols mean for the math equation, how in the world are you going to be able to verify what the answer is that they come out with is correct or not? You wouldn't, okay? You couldn't if you don't understand the way the formula works. I see on Facebook all the time this is for geniuses only, and it's one of those clickbait things that says, what's the answer to this? 4 bottles of beer, 2 lemons, and then it makes a difference on where the divide or multiplication sign is by which ones you multiply first. Or okay, so if you don't know how equations work to figure them out, you're not going to get the right answer, right? So for all these people who are going, oh, we've debunked the globe with the lunar eclipse. I mean, for crying out loud, lunar eclipses have been happening for freaking ever. It just so happens to be the first time since the 1970s where one of them is going to have a total path across the United States in the day. They happen all over Earth all the time, in the night, in the day, whatever. where you don't get to view it because you're not in its path. So I'm not trying to bust on Richie from Boston or anybody else, but you don't know what you're saying, and you're not getting it right. You're not understanding what. And I'm not in support of the NASA idiots that are making these little, models, and because they're really very adolescent, if you ask me, the way they're showing, here's the sun, here's the moon, here's the size of the giant sun, and here's the little bitty moon, and here's the big earth, and this is all the shadow that it's going to make, and here's the apogee and the perigee and the whatever. Okay. So before you jump on these things and make yourself look stupid, if you don't know if they're right or wrong, don't go making that viral. Okay. That's just me, though. I don't.
But
like
I digress.
Viral. Yeah. Well, it is a digression, but at the same time, doesn't the
well, if anything,
the whole concept of the way the moon is traveling west to east, when everybody's assuming because every other night it's going east to west, we're not talking about the path of the moon, are we? We're talking about the path of the shadow. That's what we're talking about, right?
If anything proves a flat Earth, it might be those eclipses that are viewed from the Antarctic regions or the Arctic regions. There's some very interesting things that, I've seen people online say, how is that angle going to work if the moon is here and that's here? And I'm sure everybody's touched on it. I'm sure, name it, from the people that do all the math graphics. But this eclipse, I don't know. I don't know. If anything, it's going to be interesting to actually just see what's behind the glare. Never get a chance to see what's behind the glare.
And you know what? The hype on this thing is so over the top. I mean, I'm seeing reports from, who are all these agencies, FEMA and everybody else, on, make sure that if you're traveling to see the eclipse that you have, packed food and what. I mean, there's going to be so many people traveling that day that it could be a zombie apocalypse by the time the night gets here. I mean, it is so over the top. Warning, Will Robinson, do not travel to see the eclipse because you will not be, you will not leave alive. You'll have to sleep in your car. God forbid, you might have to sleep in your car. How many times when I was a kid did we, have to do some sleeping in the car for a couple of hours to keep driving all night to get wherever it was we were going? I mean, nobody died.
We slept while we were driving. What are you talking about? We just went right over those bridges, 5 miles ahead,
going and going
in the snow.
Sometimes
we wound up on the other side of the road. Whatever.
Sometimes we would just barely pull over. The wheels would still be turning, and we'd jump out and switch seats real fast. Come on.
And seatbelts.
So it's gotten a little more than crazy. Some of this debunking stuff. Okay. So what that Vsauce has debunking flat earth videos that have millions of views on them. Do you know why? Because it's a piece of cake to debunk the AE model. And that's simply all he's doing. He's not debunking the flat earth. He's debunking the model that everyone has jumped on the bandwagon for. That's
I want to see more. I want to see more AE map people go towards the cone model. Right. I want to see them get all hooked up in a hollow earth. I want to get them.
Yeah.
I see them all mixed together and go. What would be really interesting if it's. We don't know which Earth we're on. Are we on the flat Earth? Are we on the round Earth? We got to figure it out. When you figure it out, then you're there, and they all exist at the same time. How about that?
What do you got, anyway. Lawrence?
Take it away, Lawrence.
Well, we've had all these hangouts where people are talking for 4 hours, arguing the toss about the eclipse. And I've looked at it, and it looks pretty simple to me. So let me show you my 2-minute presentation, which explains it very easily, which anybody should be able to understand. So just bear with me. I'm going to do another screen share. Okay, so I've took this from time and date. There we go. So what we've got here, we've got So this is from the 21st of August. So what you can see here, the sun, which moves just a bit faster than the moon, it's just about caught up with the moon. Okay, so the moon's moving from east to west, and the sun is. The sun's nearly caught up with it. So the sun shining on the moon is going to cast the shadow over to the west. And then in the next picture, so you can see the shadow is to the west of the sun and moon. And then you move to the next picture where the sun is directly over the moon. So here we got level, and you can see here on this one.
Can you go full screen on that, please, Lawrence? You can't see the moon because it's hidden behind the sun.
The sun's directly over.
I get that, but there's a little bitty black spot at the top that shows the moon, and I just want to be able to see it. Just go full screen for a second.
All right, I don't know. I'll magnify the page if I can. There we go.
Okay, there you go. That's better.
That's pulling some of it off.
All right, so pull that over and
anyway, so let me put that back down a bit. Yeah, but you should be able to tell from this.
I got a video of it on the regular time and date and the diamond if you want to go to it.
Okay. Why don't you send me that link? Why don't you send me that link, John?
Yeah. So you can see there the sun is directly over the moon, and then you've got an equal spatial amount of the shadows. Yeah, it's level with it. So that's why the shadow is going up to the north and on both sides. And then on the next screen, the sun has just gone after it. And once it's gone after it, it's going to cast the shadow to the other side, to the east.
Right.
So when it's just behind, it casts it to the west. When it's level, it casts it in equal on both sides. And when it gets just past, it casts it to the east. Simple as that. We don't know the size of the sun. If we did, we might be able to calculate the size of the shadow. I mean, the flat Earth thing is saying it's about 30 miles the size of the sun. We don't know that. But a 30-mile sun, 50 miles away from the moon, may well cast a 70-mile shadow. I've been doing some experiments myself today, but I didn't know we were starting so soon. And basically, I just got a light source, and I was putting a tangerine on the end of a pencil in front of the light source and looking at the shadow on the wall, and it was coming out pretty much like time and date does here. So you could do the experiment at home. You just have to work out, a relative distance of the sun away from the moon.
But Lawrence, the whole idea.
But if the sun is a filament, though.
Right. The filament. Lawrence, please, let me interject this. The reason why the path of the shadow is reversed of what everyone thinks it is because of the speed and the sun, the difference in the speed of the sun and the moon. It has nothing to do with the direction that they individually are traveling. They are both traveling in the same direction, east to west. But the sun and the moon's speeds are different, and the sun is overtaking the moon, correct?
Yeah.
Okay. This is not hard. This is not rocket science. They do not move at the same speed. So relative to each other's speed, the shadow itself is cast in reverse of what you would think it would be, because the sun's catching up with the moon's moving in the opposite direction visually, but they're both moving in the same direction, right?
Yeah. Basically, you've got the sun just behind the moon, the sun level with the moon, and the sun after the moon, and that's what it is. And you can do this little experiment at home with yourself. You'll get the same effect. It's pretty simple.
Well, but I mean, people need to literally go to timeanddate.com and put in August 21st. I'm sure millions of people have gone there and looked at it, and you can progress the sun, progress the time forward an hour at a time, and it's going to change the little picture of who's in front of who here and at what time, and it'll show you exactly what the shadow is going to do. So I can't wait for this to all die down, and hope that it's one of those things we never speak of again about the wait a minute, they're traveling in the wrong direction. The shadow's going in the wrong direction. No, it's not, relative to the passing of these two objects.
Exactly, yeah. So, John, are you going to show us about this 3-pointed Calignan thing that you've done?
Yeah, show us what you've drawn up so far. What are you looking at, John?
Really, I mean, nothing really. I don't have anything yet. Just the imagination of, you know, four sides, a four-sided object, flat triangle Earth with the ether above as an infinity prism. That's really all I got.
Okay.
I mean, right now, I mean, you get triangulation of distance. I mean, let's say it acts just like a globular Earth. I don't even want to say globe Earth anymore.
I know.
I don't know. The whole idea
can't
of
even
globe,
relate to it anymore.
No, it's not just that. It's like, I mean, is it a globe or is it globular? Is it like, I mean, is it round or is it, I mean, which one is it? And there's that. I don't know. I mean, is it a drop of something, a drop of water? I don't know. But I think, like, you know, the idea that I really wanted to explore was the idea of having an ice wall or having land beyond the Antarctic on a triangular map. That's not saying that there's the AE map. That's not even saying that it's a dome Earth or anything. Those fascinating to open up your mind to, like, you know, think about things, to explore shapes, which is really what I've been doing. Right. But no, it's just the idea of determining what above. I mean, if you have a triangulation of distance, okay, that's cool. Everyone can understand that. You know, you have 3 points equals a plane. That's it. That's all you need. Mm-hmm. And the other thing is the triangle universe really struck really hard in my mind. And I've watched some simple things that people do with the multicolor lasers, where they have just a square cube prism, and in each three sides they have a different color light, and it's going through the prism and then it's coming out white the other side. So I'm like, okay, so, you know, it's kind of like a Sony Trinitron. You got three colors and that's all you need, you know, RGB.
Right. RGB.
So, you know, how this affects, you know, do they all come from different angles of a face of the... I've come to the point where I'm going to stick with a simpler shape, the triangle, whether it's a triangle above and a triangle, you know, like two, you know, like sandwiched on each other, and one is northern, one's southern. Don't know, is it all one side and then there's the other side of Earth that we've never seen? Is it, I don't know, and I've reached a point now where I want to see what the flat Earth community, I mean, do they know their shapes and forms and you know, hyper dimensionally speaking? I mean, you know, like I said before,
some do.
Pac-Man can exist on any type of. I mean, if you want the, you know, seriously, you want the star-shaped Earth, Pac-Man. You want the triangle Earth, Pac-Man. Diamond, Pac-Man. It's all Pac-Man. I mean, if it's
but look how much fury, pushback, confusion, anger, the whole Pac-Man theory started when, you know, we brought it up. When the heck was that, Lawrence? It's been 2 years ago at least that we started talking about Pac-Man, based on the concept that there are no shortcuts on flat Earth, and you can. Since we know that we're not going in big circles to the left or to the right to go east or west, and we're not going away from north to go south, there's going to be people who are going to, you know, take what we've said about compasses and they're going to just completely attach it to the AE map and go, see, this is exactly right. All this declination just leads to the north is in the middle always, no matter what you do and no matter where you go, it's always in the middle. And
well, they've got a problem with that, though, haven't they?
Well, yes, they do. But Lawrence, what you just showed us with due east and due west from any location, 6,225 miles. For those of you who joined late, go, when this is over, go back and watch the beginning again, where Lawrence, showed us traveling at west. 270 degrees is always considered west on any compass. And you always end up, if you travel 6,225 miles, you end up at the equator. And so one of the things that tells me is that the equator is the center. Okay. The equator is the center. It is not the north. The north, it cannot be the center if everywhere you go ends up at the equator. Okay. Now, I don't know if it's possible to model what you just did on an AE map. Going due west, however you can figure that out. 6,225 miles. Where do you end up? Okay. Do you end up at the equator? No, I can see it in my head that you would not. Do you see that in your head also, Lawrence?
Yeah, you just couldn't model it on that map because east-west is a circle.
Well, because if you were in the south hemiplane on an AE map and you went 6,225 miles, you wouldn't end up at the equator, because the distance between objects is so much greater on the AE map in the southern hemi than it is in the northern hemi, that the 6,225 miles is not the same distance, basically. So,
so the equator and any longitude line, is there anything that's like, completely straight and flat without any declination difference? Any longitudinal line and only the equator.
The lines are not curved; they're all straight. You can see these are all straight lines.
Right, but the latitude, but the declination and latitudes.
Yes, all of the longitudes are straight, and none of the latitudes.
The latitudes are straight lines.
The equator.
They're not following what you would think.
Right.
Where the cardinal directions, they're not.
Right. We need to state that, Lawrence, we need to state that specifically as to what you're showing here. Okay. The longitude lines, north and south, are north and south always straight. Right?
Yeah. But east and west, they don't follow latitude. They converge.
So now let me throw a monkey wrench into this deal. Okay. Now, that we have lots of friends who are square flat earthers. They don't embrace the diamond. Now, some of them like the sinusoidal and some of them like the ATOF. Many people don't even know what I'm talking about because they haven't even taken the time to go and look at all the map projections yet in their life. Okay. Because there's no reason to go and look at that, because the world is a circle and that's all there is to it. Okay. Sorry to be so blunt, but that's the truth. Until you have, I listened to a video the other day that you sent me, Lawrence, where someone said, oh, I haven't seen the diamond map yet. Well, how can you not have seen the diamond map if you've been involved in flat earth for a couple of years? Okay. Number one. Number two, we didn't make up the diamond map. It is called the Collignon projection of the globe. That's what it's called. It has a name. We didn't make it up. Okay. And you can go to any map site that has all of the globe projections made by everybody over time and what their purpose, they all have a purpose. They all were created for a purpose. It wasn't just because, oh, let's see if I can make a new projection just for shits and giggles. Okay. They did it for a reason. So the diamond map is called the Collignon projection, and it's a projection of the globe. One of the reasons why Lawrence latched onto it to begin with was because he and I both agreed that we have to use the globe data and the map data that we've, that it works in the real world. Planes fly these distances. People travel on these maps. People go from A to B. And when it says it's going to be 6,225 miles, your odometer says that they agree. Okay. And so the point of latching on to the diamond map was that The longest distance is the equator, which is 24,901 miles. Half of the distance from the equator is the distance perpendicular to that, which is from the north to the south poles, okay, which is 12,000 whatever it is miles. And the Tropic of Cancer and the Tropic of Capricorn are pretty hard to find the distances for, I might add. You can Google the crap out of those two numbers, and they will give you every kind of excuse for why there's not a really finite number for the distance around the Tropic of Capricorn and Cancer, because they move a little bit every year, or they move a little bit, you know, according to where the sun is tracking. And whatever that's about, I don't know. But if you can track down these two numbers, they are very close, and they are 5,000 miles difference from the length of the equator. Or, yeah, right? Isn't that right, Lawrence? 5,000 miles difference from each one.
I need to look it up, Laurie.
Okay. Well, the point is, we're using the data that can be cross-referenced from many, many sources. And so that ended up being as close as possible to the diamond map. Now, are the sides, you know, little pointed diamonds, you know, pointed triangles? No, because as you move, that moves too. It would be like, the closest thing I can come up with is back in the day when I was a kid, we used to use Reader's Digests, and we used to fold the pages down, every page down in the Reader's Digest, and pull the cover and the back together and glue them and spray them green, and we made a Christmas tree. Does anybody remember that? Does anybody remember at all doing that?
Does anyone remember Reader's Digest?
That's the Wayback Machine, right? Well, it didn't have to be the Reader's Digest, but there was like so many of them laying around because you got one all the time, okay? But the point of it is that it was a flimsy magazine. You could fold the pages easily, and you could, you know, pull the cover and the front and back covers together. The idea is, though, it fans out, okay? When you pull the back and the front covers together, you make a little round Christmas tree with the pages folded down. As you move on this diamond map, okay, that's the Pac-Man effect. The next page happens, and the next page happens, and the next page happens as you move east to west, okay? And it doesn't happen when you go north to south. There's only a finite north and south, because nobody's ever gone, that we can trust this data. No one's ever gone from the South Pole to the North Pole and back down to the South Pole on this imaginary globe. No one's done it on a flat Earth either. Okay? You get to the top, and let's say you're traversing east to west at the top. You're going to end up Pac-Man there too. You're going to end up back at the same place that you started. There is no over the top and back down the other side again. Now, you could probably come from here. You could probably come from right here and go east and come out over here and go back down, okay? But you're not going to go completely around a circle like a longitude line. You could not follow the same longitude all the way around. Do you guys agree with that? That it's never been done or never been documented?
Oh, yeah.
It's never been done. You know, we just don't know what's there, do we? That's the thing. It's
okay. So that's why all the hoopla. That's why, you know, you can hear us talking right now. Is anybody 100,000% sold on the diamond map being the map of flat Earth? No, because it has some problems too, a little bit with distances. And it does have what appears to look like bent longitude lines. Although, the more I see what Lawrence's drawings are turning out to be, and you end up at the equator when you're going east to west, something about those bent lines doesn't seem quite so contrary anymore. But at the end of the day, all we're doing here is we just keep showing you what happens when, okay? We're not saying that we 100% agree with this or with that. We're only showing you what happens when. So what happens when Lawrence goes on the globe on Google Earth, sorry, and travels 6,225 miles due west. He ends up at the equator from whatever point on Earth he starts at, okay? Wherever, doesn't matter. And that right there is a clue, because the globe is modeled to the flat Earth. Therefore, we have to model the flat Earth to the globe. It is a yin and yang. It both works. The only thing that doesn't work is that darn curvature, okay? There is no globe curvature. So people think they see it. Okay. There's no way you can convince someone that they didn't see a black cat when they think they saw one. You know, the whole Matrix thing. Although the glitch in the Matrix, I saw the curve. Okay, if you think you did, and you're looking out of a curved window in an airplane with a curved fuselage, no problem. That's what you think you saw, and then maybe that's what you saw. But there's anomalies associated with that cause that's what you saw. So go look out the cockpit window. Many airline pilots every day are showing footage out the cockpit window, and it's not curved out there. So, all right. So now back to compasses, because I want our whole purpose for starting this whole thing and saying, you know, ha ha ha. Lawrence said, title this, you know, the hangout, there's no compasses on flat Earth. Well, there certainly are compasses, and they certainly do work over short distances. What we're calling into question is, how do they work? What is that needle being drawn to? Obviously something magnetic. Is it magnetic? Is it electromagnetic? Is it pointing up? But it can't, because it has to go this way. Is it pointing down? But it can't, because the only way to make it work is to hold it flat in your hand, right? They don't have a compass that has a needle that points out the top that I've seen, or one that, you know, is a little ball and it points down to the bottom. What good would that do anybody? There's south on a flat plane. How does that help anyone find anywhere, right? So the only way that a compass is useful is for that needle to point to north. And once you find north, then you know that way's east, that way's west, that way's south. That's how you use them. This declination thing that comes into play, you've got scientific agencies like NOAA, NASA, Goomba, whoever, working in different places on Earth, deciding what the declination is. How many of those places are there, Lawrence? And how are they figuring declination? Based on what? You're muted.
Yeah, that'll need to be for another show, Laurie. I found a whole lot of information. They have these stations. I was just looking at the UK ones. They have these stations, and they actually, you can go on there and they show you the equipment that they use, and it's all mumbo jumbo pseudoscience. It's got to be made up, and not only have we, you know, you've got true north, you've got magnetic north, and
yeah,
you've got
geographic north and magnetic north.
They just throw so many variables into the pot and saying this affects this and this affects that. You know, if that was all true, nobody'd be going anywhere. The fact is, we're on a flat Earth, and you should be able to navigate quite straightforwardly with the compass. But it would appear that that they want us to think otherwise.
Well, I guarantee you that it won't be long before, because all of these hangouts get made into podcasts, MP3 podcasts, and they're literally planted all over the place for people to listen to. We have many, many more. Do not be confused by the view count on our YouTube channel, because the listen count on our podcast is well over 1.5 million on just the videos that we've posted there. So I get messages all the time on the website, and I encourage anyone who has good information or an idea or thought about this whole compass thing and what Lawrence has shown us on Google Earth with the east-west ending up at the equator thing. Please send me a message and let me know what you know or what you found out. And if you're somebody who uses compasses, now I don't want to hear from a bunch of declination people, but if you have some valid explanation for how declination works and you'd like to educate us, we'll be the ones to decide whether your information fits within what is observable, testable, and repeatable or not, which is actual science. But please contact us and let us know what information you have, or if you even just have a, whatever you call it, brain fart or inspiration or whatever, that it goes with something else you've been thinking about, then please let us know that too. Because we're here to learn from each other and also learn from the people that are listening and joining in. So I don't know many other people that have actually talked about this a whole lot as far as flat earthers go. Most of the time they stay away from this whole directional thing because they're AE map people, and that's a very confusing subject, as everyone knows. We finally got through, after a couple of years, the whole thing about, those flights in the southern hemisphere don't exist. They're all set up and fake, and people don't actually fly those. Well, many people have proven since then that the distances between South America, South Africa, Australia, New Zealand, and back around again they don't fit the AE map at all. And those flights do exist, and people actually take them. Now, whether or not a plane jumps up north and picks up people in Dubai and jumps back over to Sao Paulo, okay, we have no way of knowing why they're doing that, but they don't have to. I saw a flight that went from Sao Paulo to Cape Town, and it was a 2-stop flight, and it stopped in a little place in South Africa, several hundred miles away, as its first stop, before it went on to Cape Town. It wasn't like in the middle of nowhere for refueling. And so, stop with the mythology, take the time to investigate for yourself, and don't just listen to what, whoever, Jaron, Eric, Bob, any of these other people who are staying with the AE under duress, don't care what anybody says. I'm sticking to it because I can't wrap my mind around your Pac-Man. Your Pac-Man is ludicrous, and so therefore I have to stay with the AE. Nothing could sound sillier to me than that. But because you can't understand Pac-Man, or you don't agree with it, it could be a concept of how this whole thing works. The rest of it doesn't work the way you have it all figured out. So anyway, all right, you guys, anything else to add?
Yep. Treasure map
on this
Tim,
particular
right? Treasure
map Tim.
Yeah, he put that email about, and he said we should talk more about the shortcuts. So I've got a little presentation on the shortcuts.
You do? Okay.
Yeah. Just bear with me.
Cool. Jump in there.
Oh.
Shout out to Treasure Map Tim.
So, hi, Treasure Map
Tim. For those of you who don't know who he is, he's like the email captain of every known email from every flat earther channel everywhere. He's got them.
Right. Okay,
so communicates with everyone.
Right. Anyway, no map. There can be no flat Earth map that works unless there is some kind of Pac-Man effect, or with tonight's possible theory that there's a reverse side to the Earth that covers half of it, and somehow we flip onto the other side without realizing it. But here we go.
You're going to have the Mandela effect people all over that one, Lawrence.
Here we go. This is stuff that, you know, is verifiable. The world's farthest apart city pairs with a population over 100,000. Rosario, Argentina, to Xinghao in China, which is 12,425 miles. Luan in China to Rio Cuarto in Argentina, 12,424. And Cuenca, Ecuador to Sabang Jaya, Malaysia, 12,421. So the thing is, you can show me any map and you're always going to have a distance of at least 25,000 on the map. So let's start off with the ubiquitous equator, sorry, ubiquitous Mercator map. So from top to bottom is 12,450, and across from left to right it's 24,901, and from corner to corner it's 27,839 miles. So if you wanted to know how I work out corner to corner, a squared plus b squared equals c squared. So you multiply 12,450 by 12,450 and 24,901 by 24,901. You add the two together and you find the square root of that, and it comes to 27,839. So here's my little pointer. If there was a boat there in the top right hand corner and it had to get to top left hand corner, and it had to get to the bottom right hand corner, Mark Sargent would say, well, the only way you can get from there to there is by traveling 27,839 miles, because there's no shortcuts on the flat Earth. But reality tells us different, Mark. You won't address this point because you cannot. So there are shortcuts on flat Earth. Otherwise, you'd have to go the long route every time. Let's have a look at some examples. So here we go. We've got, let's start off with Los Angeles to Tokyo. Let's find that on, here's the flight distance, okay? Official flight distance, which is verifiable by the flight times, you know, about 500 miles an hour. And, sorry, I've got Sydney to Santiago. Let me get the other one. Sydney.
Boy, is that a great circle route.
LA to Tokyo. Yeah, here we go. LA to Tokyo. So this is going over the international date line, and the distance is 5,487 miles. So Mark Sargent is saying that you can't take this flight. It's not possible because there's no shortcuts on the flat Earth. But, you know, millions of people do take these flights. They fly off the edge of the map is at the international date line. They fly off, you know, they fly west, and they continue west, and they end up in Japan. So if you look at that on one of these maps that has several maps in one, on this one here, you'll see what the alternative is. So Mark Sargent is saying, yeah, you want to go from Los Angeles to Tokyo, you're going to have to fly to the east, 14,000 miles. You can't fly west because there's no shortcuts on the flat Earth, only on the globe. Well, he must believe we live on a globe, because you can take these shortcuts. Whatever features exist on the globe have to exist on the flat Earth, otherwise we would have spotted it. Yeah, and then we'll look at Sydney to Santiago. Here we go. Sydney to Santiago, 7,063 miles. And in this case, the plane flies to the east, 7,063 miles. And when we look on a Sydney to Santiago on the Mercator map, here's the alternative. So they were saying, oh, no, you can't go that way. You can't fly east. You've got to fly from the west. So instead of flying 7,000, you've got to fly 12,500. Well, that's over half the distance of the globe. So you couldn't do that anyway. It's a nonsense. The whole thing's a nonsense. Shortcuts exist. There we go. Let's have a look on the globe. What it looks like. Sydney to Santiago, east, 7,000 miles, which is that one there, where my pointer is. They're saying, no, you've got to take this one, the long distance route. It's an absolute nonsense. You know, we're going to take
well,
the short.
they're telling you that because you can't fly, so-called can't fly over the South Pole.
Well, even if you did, it'd be just as far anyway.
Yeah.
Because you've got all that curvature involved with it. So, you know, it's a complete nonsense. You can get any map you like, and you will have a map. You'll have the distance between any 2 points is going to be at least 25,000 miles or 24,901. You can take the AE map. You know, let's bring up the AE map. Can I find one on here somewhere? It's 25,000 miles across near us. Damn it, I haven't got one here. But you look at the AE map.
You got rid of all your AE maps.
You know, I got rid of them. Yeah. You know, you look at the AE map, and it's, you know, you've got the North Pole in the middle, and you've got the South Poles on the outside, so it's twice the distance. North Pole to the South Pole, just under 12,500 miles. Multiply that by 2, and the distance across the AE map is 25,000 miles. But in reality, you know, the maximum distance between any 2 points is 12,400 and something miles. You know, so anybody, Antonio Subarats, has come up with a map. You know, he's not done any distance calculations. You know, Awake Souls and Ronnie, they've come up with a map, but their map is a complete nonsense as well, because it's all over the place, and they've got, you know, they've got bits here and bits there, and the sun going all over the place because they've bent all the lines of latitude.
Well, then that's the declination. There's the Reader's Digest Christmas tree I was talking about. For those of you who've never made one, I don't know if they still do this in school with little kids, but anybody who's an older adult probably made one of these. The idea is that I was trying to say is moving from east to west, you're not going to notice any difference. You're just going to be on a different page. Okay. That's how Pac-Man works in my mind. It doesn't just automatically zoom you from, and then people will say, oh, well, that would have to be rotating. Now you're back to a spinning globe. No, you are on any one of those pages. You go to the next page. That's how Pac-Man works. Okay. In my head. And, you know, I know that people say, well, you know, Thompson talks about the ether. I also completely understand and agree that there is something to do with lack of time and space in this whole thing, and possibly being able to travel through the ether or in the ether. I'm still trying to work that out in my head. But it is a very interesting concept, and I know that Thomas has spent a lot of time thinking this through, and I've sort of followed what he's been talking about. But for the purpose of explaining the shortcut idea, you know, if you look at this concept here of the, you know, this is an upside down oblate Christmas tree, but think of it as moving, any individual moving from page to page. Most people can't travel any faster or any farther than they would be able to tell the difference in time, space, whatever. So that's that. Just a way to explain the idea. So, thanks for that whole thing, Lawrence, on shortcuts, because it's obvious that you can go the distance, east or west, and come back to where you started, and which is one of the reasons why they were able to sell us a globe, and that nobody fell off the edge. So there's no edge, and you know, if there is an edge, we haven't found it yet. If there's a ice wall, or a dome over an ice wall, we haven't found it yet. And so I know my picture on my channel says say the dome one more time, I dare you. I know it, and I know that it says that, but that's because for the longest time I heard dome, 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 and dome makes rainbows, and dome makes sundogs, and dome makes echoes and thunder, and all of these, you know, comparisons. And to me, it's nothing but mythological dogma and cult repeated mantra stuff in my mind, because I don't relate to this whole snow globe terrarium thing. And I'm only saying this, most people who've been listening to us for a long time know that, but for new listeners, you need to investigate the idea of the circle model and the dome over the top and the ice wall around the outside and the little circling sun flashlight and all that as complete flat earth dogma, and that it is hitting the mainstream media more and more on a daily basis. And every single time I see it talked about in any mainstream article, and Lawrence just posted one again in the group yesterday or the day before from the UK, was the second largest read circulated rag, for whatever other thing you want to call it. And that's exactly the model that they had in there. And it's cringeworthy every time I hear ice wall, dome, you know, circling sun and moon, and people just debunking their crap out of it. And it's sad that people have clinged to this so tightly that they won't even hear you. They just do the no 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 when you start to explain these problems that Lawrence has just talked about, that we've talked about ad nauseum for 2 years now. So if Einar, if you listen to me and listen to any of our videos after I sent you a list, and that was enough to make you forget about finding the curve, then that was not my intention. If that, and you know, I know he's probably laughing when he hears this, because I'm sure that that's nothing to do with little old me. But for who Michael Pika or whoever you are, trust me, it one has absolutely nothing to do with the other. And if you think that our dissing on Eric Dubé and his repetitive, of course, now he says, I don't adhere to any certain model. If you think that that was enough to queer the deal, I guess is the old saying, then too bad for Einar, because that's not how it works. If you truly are looking for information and truth, you don't just ignore that which doesn't go with your confirmation bias and your normalcy bias and every other psychological hold you have on your belief system. So, okay, that's all I have. You guys have anything else you want to add?
Did I cover the flight dynamics thing last week, Laurie, the last time you were on? Did I cover flight dynamics?
Flight dynamics? That doesn't sound familiar.
Well, it's worth showing again. So if anybody hasn't seen this, then I've got that on my little file. Just bear with me a second, and then we'll probably be done. But this is from a flight dynamics instruction manual for people who study, you know, flying. And this is what it says. There we go. Here we go. Where's that? Oh, sorry, it's in the other one.
I love it when you're ready, but you're not really ready, Lawrence.
There we go. Flight dynamics, and you can buy official books that say this. So this is, you know, for people who study the flight dynamics of aircraft, which you presume is pilots. It says you got section 1 introduction, section 1.1 basic concepts, 1.1.1 controlling an aircraft, and then 1.1.2 making assumptions. And it says In this summary, we want to describe the flight dynamics with equations. This is, however, very difficult. To simplify it a bit, we have to make some simplifying assumptions. We assume that there is a flat Earth. The Earth's curvature is 0. There is a non-rotating Earth. There is no Coriolis effect. I mean, come on. If you were flying, really flying over a globe, you've got the spin of the Earth, and you've got the curvature of the Earth, and you've got all the winds that are going to be generated as a result of all these forces going. And these pilots are told they have to assume the Earth is flat and there's no curvature.
Can you scroll?
That's
can you
basically
scroll
saying,
that?
look,
Can you scroll that screen, Lawrence? Can you scroll the screen up a little bit, because the little box at the bottom is blocking it?
Sorry.
No, I guess the
just
trash can box or whatever that is.
Just bear with me, and I'll get the actual thing.
Okay, so that came from a flight manual.
You can buy it in a book as well.
Okay, it came from a flight manual book.
Earth assumptions. If it comes up this time, flight dynamics. Hopefully, I'll get it again. Here we are. It says www.aerostudents.com flight dynamics. So it's the first thing that comes up. Go onto your search engine and type in flat Earth assumptions, flight dynamics, and it brings it up. And here we go. So we can read the whole thing if you want. There's lots of pages. Here we go. Making assumptions. There is a flat Earth. This is in section 1.1.2. There is a flat Earth. The Earth's curvature is 0. Well, how can you train to fly an aircraft over a spinning ball with shitloads of curvature if it's flat? You know, there's no comparison between the two. So it says there is a flat Earth, there is a non-rotating Earth, and there's no Coriolis effect. And I've posted this on various other channels, totally ignored. You know, so it begs the question, if I was going out on the streets chatting to people, I would print this off. In fact, I'd buy the book and I'd just take the page and say, well, you know, when they train airline pilots about flying, they go through flight dynamics, you know, and there's shitloads of pages. You can go, you know, all sorts of complicated equations, but all of these equations are on the basis that the Earth is flat, because they have to, because it is flat. But they say that, you know, it's very complicated, so we'll simplify it and assume it's flat. It's so ridiculous. You know,
it's completely ridiculous.
Chatting to Globers, show them this, and they're going to have no answer to it.
So their own manuals, their own flight training teaches them to fly on a flat surface, on a non-rotating surface, and there are no rotating masses like turbines. Gyroscopic effects can be ignored. And there is constant wind. Why did they say that? There are no rotating masses like turbines. Gyroscopic effects can be ignored. But I mean, a gyroscope proves a flat Earth, as many people say. And then there is constant wind, so we ignore turbulence and gusts. Now,
yeah, but how could you ignore curvature? You know, if you ignored curvature, you're going to fly out into outer space, aren't you?
Yeah. Well, I mean, many people have asked pilots about that. Do you dip the nose down as you fly X 100 miles, blah, blah, or wouldn't you be rising above the plane of the Earth? No, we are just following curvature. The plane just stays level and we're just flying around the curvature. That's what they think. Yet you just showed us that these assumptions are not included. It's like no curvature in the Cracker Jack box.
Yeah, who are they going to tell?
Included.
You know, who are they going to tell? Yeah, I'm just training to be a pilot. By the way, they've told us in the training to assume the Earth is flat and there isn't any curvature and there isn't a Coriolis effect. So what they're saying, the Earth is flat, yeah, there is no curvature, and Coriolis effect doesn't exist.
Well,
Otherwise,
I mean, I
they'd have
guess
to
in
include
other
it.
words, if you were training for flat, what, John?
They're technically not saying that it's flat. They're just saying we're going to apply everything to something that's flat. And you know, everyone goes along to get along. And they're like, oh, yeah, I know, yeah. Oh, I know. Yeah.
They have no idea why they're doing that.
Right, exactly. And there you go. Go fly
some
the plane.
expert, some technocrat, some expert, some scientist decided that, you know, it's just way too much math for you pilots. You're really not, you don't need all that.
Just
it's not
drive
necessary.
The plane flat.
Just fly the plane. Just turn on the engine, do the checking at the beginning of the flight, make sure that you got fuel in there.
Look at some of this map.
Close the door before you take off and punch, you know, the button that says LA to New York.
Oh,
go.
Autopilot.
LA to New York, go. And the rest
Laurie.
of that, oh, it's just a bunch of math. You don't need to know all that. Just don't worry.
It's just
your
one big McDonald's keyboard.
This is the math here. This is the math for flying on a flat Earth, because that's what it says at the front. We're assuming it's flat. Look how complicated that is. None of us would know what that meant or could work it out. And then you've got to factor in the curvature. Then you've got to factor in, you know, the Coriolis effect. Then you've got to factor in the spin of the Earth. They just couldn't do the math for flying over a globe. It would be impossible.
Well, especially because if you were just going east to west and you wound up at the equator, and you didn't want to go to the equator, you wanted to go to Boston, but you ended up in the equator. Gosh darn it. And you have no idea why. You know, the length of the distance of your plane is only as far as the A and B in the gas, so or fuel. Okay, so you know, these are all kinds of things that people are so used to seeing debunking stuff, or they're so used to experts coming in. Oh, you just don't know because you don't have a master's degree in aviation mathematics, so you wouldn't know that this is how we do it. Okay. And so the people say, well, so they're so tired of hearing that's why you can post that all over the freaking place, Lawrence, and no one's going to respond, because what are they going to respond to? They're going to go and take it to their pilot friend. I mean, everybody has somebody that they know in their circle of friends, at 6 degrees of separation thing. Everybody knows somebody's a pilot or has been a pilot, training to be a pilot, whether it's a private pilot license or a commercial pilot license or whatever, to take this information and go ask them. Because, you know, if you go to aviation school, that's got to be in the manual, right?
Yeah, and we've had people like Mark Sargent with pilots on his show, and not one of them mentioned this. So it begs the question, are they really pilots or people pretending to be pilots?
Well,
there have been various pilots on, not one of them's mentioned
that's
this.
Part of the problem with that whole hide your face, disguise your voice, do an interview. We can't say your name because your job's at stake, yada, yada. Okay. That's what happens. And then people go, oh, that's not really a pilot, or he's not at liberty to say because somebody will, you know, argue his point or whatever. So at the end of the day, what it really comes down to is, once you hear about flat Earth, you're either going to do A or B. A, you're going to go and research it. B, you're going to go with the mainstream of people and go, oh, it's so like flat tard of everybody, and I can't believe how ignorant this all is, and I don't even want to look at it. Or, all right, I'll take a cursory look at it. I'm going to stumble upon the flat Earth map and model, and I'm going to debunk the crap out of that thing real quickly, which is some common sense. And then I'm going to say, you know, that they are flat tards. So one of two things happens. You either do some serious research, or you know, discount it out of hand. Now, if you start doing some serious research, you will find out that you didn't know diddly about where you live. Even if you knew we're like 100% right on, bang on with the whole globe model, you still didn't know diddly. Most people don't have any idea where stuff is, what latitudes and longitudes are, what's on what, where. They didn't ever hear about the Coriolis effect, or they didn't know that the sun moves between Capricorn and they don't know a whole lot of those things until they start investigating. And then you sort of become this little mini expert on all of the catchphrases, I guess you would call it, of flat Earth. And you think you know a whole lot of stuff until then you start breaking down what you thought you know and try to start comparing it to what you observe. That's where the real rubber meets the road, is going out and making some observations. And the whole idea is to question everything. At the end of the day, that's simply all it is. What is everybody so pissed off or afraid of? It's just, we're just asking questions. When did that become like, you know, oh, you're persona non grata because you're asking too many questions? And all these people who say, oh, so-and-so's channel got taken down because they, you know, they asked too many questions, or they made too many, you know, they said too many things that got the Illuminati all upset. Well, what are we, chopped liver? We never got taken down. We've never had any, you know, strikes or hits or anything else. And then there's going to be this person over here is going to go, oh, that's because you're a shill. You're paid for by the people who are keeping your channel up there. And you go, you know what, whatever it is, I can't win. Nothing I could say will convince you. It's really okay. Listen if you want, turn it off if you don't really care. But that's the whole end of the story of whether or not you truly can consider yourself a researcher. Look how much time it took for Lawrence to go and dig up, get on Google Earth and say, Lawrence, you saved every one of those little paths too, because you could go back and click on those and put them all back on there. I was like really amazed at that, because that right in by itself takes time. Just save as, save as, save as. But you did it, you know, you came up with a question and you pursued it to a point of, this is curious. And then we come on and we talk about it. That's what we've been doing for 2 years. If that makes us shills because we question the AE circle thing, blah, blah, and all of its little component parts, then you guys need to look up what the word shill means. That's for sure. Okay. So, all right. Thanks, you guys. I think we'll wrap. And thanks to the viewers that were watching live. Thanks to the podcast listeners who will listen later. And if anybody has any questions, put them in the comments, and or send me a message via flatearthconspiracy.com. Become a subscriber, I guess, and you can send me emails. And if it's for me, I'll answer it. And if it's for Lawrence, he'll answer it. And if it's for John, same there. I'll forward it to whoever. And if it's a legitimate, real stuff. If you just want to call us shills, well, delete. No big deal. Okay. That's it for me. How about you guys? You done and done?
Good night, ladies. Yeah. Now you guys.
Yes. Good evening.
Okay. Thanks, guys. See you. All right. See you all next time.